Hello, and welcome to problem 977 of course storage arrays. First of all, we're going to begin with reading the description, and after that we'll jump into the solution. So you probably see here some options that we have already, but let's begin. So given an integer array of numbers sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. So the first thing that we already know is that the numbers is going to give us in here is going to be sorted, and it's going to be in non-decreasing order. So that's going to be very important for us to know whenever we're doing our checks. Now, return the array of the squares for each number sorted in non-decreasing order. So we have to return a sorted array, which is pretty cool. Now let's take a look at examples. We have numbers from -1 and so on, because this is an integer, and integer also includes negative numbers, as here we can see also in the constraints. And also here the constraints, you see this sorted in non-decreasing order, which is already explained in the description, but it's always good to know that is part of a constraint. And here we see the order, and here we have the answer for that. Now, one thing to keep in mind is that you can have, for example, a -3 and a 3 in here. And both of them, if you square both of them, you'll have 9 and 9 also included there. So that is one thing that we can have in mind, and once we start working with this. Now, there's also one follow-up that we can check, and that's the O(n) solution. But let's begin with a brute force solution, so we can have it. Now, the brute force solution will have an n log n. And then, because the first thing that we'll do is just, if we see here step by step, the first thing is like just double each number. And technically it's just going through the array, loop the array, and just double it. And the second thing too would be sort the array. Once you have a list of that, once you have a list of double numbers, just sort it, and then you'll have the answer. So let's begin by creating an array called double, and make sure it's an empty array, just to make sure we have those numbers doubled. And let's have a for loop of num in numbers. Then for each one of those numbers, just add that to double, and after that say to the power, actually it's append. We have to append those ones, and after that we have power of each number to the power 2, and we'll be able to have the array of sorted numbers there. Well, actually double numbers. Now the second one we can have is we already talked about having that as an array, so let's just sort the array, and then return double. Because we're trying to do this thing as a brute force, we already know that this one is going to have some numbers. Okay, so there's probably one in numbers. It's called nums. Tap that. Okay, perfect. So now we have this as an option for both cases. We already know that this one's going to run and return the right output. But here's a trick. N of log n, just too slow for what we're trying to do. So let's try to find an optimization and have a O(n) solution then. Now for this, we're going to have to be a little bit more specific of what we're trying to create. And the first thing is just basically to find the largest number and append it to the back of whatever we're trying to create. And there's one way to do this. So for example, we have 4, -10. Yeah, actually this one's a good example. Let's begin with this one. Now here's the trick, that you have -4 and 10. We already know that this one is going to be a sorted solution. So we already know that -4 is going to be the lowest negative number that there can be in an array, and 10 is going to be the highest positive number that's going to be in the array, because they're already telling us it's a sorted it's a sorted non-decreasing order, which is fine, which is great actually for us. Then we need to know the position of this one, and we need to know the position of this one. So that's great. Let's begin by creating, first of all, and we already know that, for example, also that if you can tell in here that the size of the numbers is going to be the same size as the output. So the array is going to be the same size, just to begin with things. So that's pretty cool. We already have that option for selecting that option. Now let's begin with an option for, let's see, creating an empty array, because we already know which one is going to be the last ones. So let's create an empty array. Let's call it this, the answer, basically, because we already know this is the answer. Now let's create an empty array with full zeros. In order to create an array with full zeros, you can just have 0 for whatever inside of that. And if you see that option, let's print it and see the option there. You'll see that this is actually an array that returns all zeros. You'll see that it's an array creating all zeros. Great. So now we have an array that creates all zeros. We already know that half the size. And we'll just need, first of all, a position. So let's create the lowest position. The lowest number index. And this is going to be 0. And the highest number index. And this is going to be the length of the numbers, because we know the length doesn't change. And let's get -1, because it's basically, it always begins from 0. Great, so now we have both positions, and let's begin doing the loop. So for the loop, let's try to have an index, because we're going to start with the highest one and append it. So technically, say for example, if this is 4, or actually this is 5, then if this one gives 25, so say for example 25, and the lowest one has an absolute value of 4, and after that will be 16, so 5 is bigger than 4. So therefore 5 squared needs to be appended on the back. Otherwise, let's say for example this is 4 and this is -5, then we take the absolute value of the highest one, which is this one, 4, and the lowest value, the absolute value of the lowest one, and this is 5, and we know the lowest one will be, because the absolute value of the lowest one will be 5. So we append, we basically change the value of the index for 5. So great. Now let's begin with an enumeration. So let's begin for index in, we'll basically need to create an enumeration. We have to go from the index from the back to the bottom. So technically it would be, for example, we don't want to use enumerate. So we already know that this is the length of numbers, but we want to go from the back to the bottom. So how would we do this? We reverse it. I think I misspelled reversed. There we go. And there was one thing I think I'm missing. Hold on. Okay, so another thing that we'll need to do is loop the array. And we're going to loop the array from the highest position index to the lowest position index. So that will be, example, for index in, we're going to have the length of numbers. But we also need to have, this is one as a range. So let's begin with range, because we want to go from whatever number we have as a range. And also because we want to have from the highest to the lowest, we're going to go with this as an option for reversed. Great. So now we have the highest index, and we can always confirm that by just doing print index. And let's click on run. It's always good to have, whenever you're in doubt, it's always good to have some testing to see if you're going from top to bottom. Yeah, 4, 3, 2, 1. So we're going to get the highest value of each one of those cases into the lowest one. Great. So now it's a matter of finding the positions. So we're going to have the highest number and the lowest number. So this case would be nums. So let's call this lowest number. And this would be nums in lowest num index. And then after that we have highest number, highest num. And this would be nums with a highest num index. And then after that we'll start comparing. So if the absolute of lowest num equals to the absolute of highest num, or is actually greater than the absolute highest num, then we know for a fact that the lowest num is going to be higher. So we're going to say that let's see, answers and then index equals to the lowest num, the power of lowest number to the power of 2. And then, because the lowest number has already been added there, we're just going to increase the value of this. Equals plus 1. There you go. Else, we know that the value can be either equal or higher. Then we're just going to go with answer. And I believe I'm missing one of them. The answer equals to index. Going to be equals because we know that it's going to be either greater or equal to the power of the highest number 2, and the highest num index equals to minus 1. Lowest num index. With that position, we already know that it's going to be only going through this loop once, and we already know we're going to have the highest and lowest one. So with this said and done, let's try to run this one, and always try to just read the code and see what's going on. We already have we're taking a space of complexity 1 because we're creating this array. It doesn't matter how. If the array is already part of the list, we already have to create one space of n, and the time of n is going to be 1, and because it's going to go through the loop once. So let's run this one and see. We have a runtime error. Great. Let's see what it is. Highest number. Okay. Highest number is not defined. Do you mean highest number? Okay, let's try to maybe I misspelled, but I cannot see it. Is that the only one? Highest number is not defined. Did you mean highest num? Oh, okay. It says high test. Highest. Guess I cannot spell today. Great, so now runs. Let's try to submit this because we have to test. And great, that's pretty much it. So thank you very much for watching this. If you have any questions about this, or even if you have older solutions, be happy to read some of those. Yeah, thank you very much and have a great day. Take care.